Hello, my name is Bruno Pedrosa, and I'm here to present you an experimental investigation performed to assess the fatigue resistance of bolted connections using injection bolts in a context of a bridge strengthening scenario. Fatigue damages started to be a serious concern since many old metallic bridges reached a significant level of degradation due to the increasing traffic levels that they have been subjected. Thus, there is a need to develop innovative methods for repairing and strengthening operations in order to prolong the service life of these structures. Recent studies have shown that within the structural damages that can be found in bridges, those related to fatigue are the most frequent ones. Moreover, in what concerns failure modes, fatigue causes reach nearly 70%. As is presented in these pictures, one of the most frequent fatigue damages in bridges is a crack in riveted connections. In this sense, it is clear that innovative methods should be developed in order to improve the fatigue strength of these details. Okay, so the main objective of this investigation was to assess the fatigue performance of preloaded injection bolts and establish a comparison with standard bolts. And at the same time, we were focused on studying the capacity of this technology to be implemented in a strengthening scenario as a strengthening method of all riveted bridges, namely in its corroded areas or by replacing unreliable riveted connections. We also want to understand the adaptability of the design curves proposed in Eurocode 3. Adaptability for these details. So, injection bolts can be produced from standard bolts, adapting them for the resin injection process, as mentioned in the next K of EN 1090. The clearance between the clearance between the plates and the bolt shank is filled with a structural adhesive, normally through an injection hole in the bolt's head. And after the curing process, it is intended to obtain a slip-resistant connection. So this technology has been used especially in the Netherlands, and no structural problems have been reported. In what concerns design recommendations, fatigue design recommendations, the design curves proposed in Eurocode 3 Part 19 are defined by the detail category 112 for double shear specimens, double shear joints, and detail category 90 for single shear joints, with no distinction between joints with injection bolts and joints with standard bolts. So a total of 45 tests were conducted using single and double shear specimens, injected and uninjected, using injected and non-injected bolts, and tested under 4 different stress levels in order to be able to define a Hessian curve. Since the goal is to reproduce as close as possible a structural strengthening scenario, specimens are composed of puddle iron plates extracted from structural elements of a Portuguese bridge designed by Eiffel in 1886 and by steel plates made with S355 steel. So specimens are composed by 2 high-strength M24 bolts preloaded with 70% of its ultimate resistance. The adaptation of the bolt for resin injection was performed under the recommendations of EN 1090. The resin chosen is the epoxy-based resin, Cicadur 52, which is characterized by its low viscosity, good adherence to steel, and good mechanical properties. In fact, the viscosity is an important aspect because it is essential that the 1 millimeter gap is completely filled with the adhesive. Okay, so experimental tests were conducted under load control with stress ratio equal to 0.1. The frequency was set to 5 Hz, except for high cycle fatigue tests, where the frequency was set to 10 Hz. So here you have the results for single shear specimens with the number of cycles at failure. Two specimens reached 5 million cycles without failure, and they were considered as runouts. Failure was obtained in puddle iron plates, which have a significant amount of heterogeneities, this material, and therefore lower fatigue strength. After each test, the adhesive was also analyzed. So presenting the results in a Hessian format and applying a statistical analysis, a mean and design curve, which means characteristic curve, was defined for both injection and standard bolts, which corresponds to P equal to 0.5 for mean curve and P equal to 0.05% for characteristic or design curve. From the value of the coefficient of determination, R square, it is observed that using injection bolts is essential to decrease the level of scatter in the results. Okay, in terms of fatigue strength, it is not clear the beneficial effect of using injection bolts in this case for single shear specimens. In fact, for single shear specimens, the eccentricity of the load lead to lower influence of the resin that is present around the bolt shank. And in this sense, it was decided to analyze all the data together for single shear specimens. And on the left side, we see the comparison with Eurocode detail 90. And it is evident that it is not a safe design criterion. This standard is not recommended for specimens in which fatigue failure is obtained in components of old metallic materials like puddle iron. On the other hand, the proposal of Tires and Greiner is a good approach. The graphic on the right side shows mean and design curves using Wavell distribution, and the results are similar to normal distribution. Now for double shear specimens, failure was mainly obtained was obtained mainly in S355 steel plates, which was expected by the configuration of the specimen. 4 specimens did not fail until 5 million cycles. Okay, so they were considered as a runout. Mean and design Hessian curves were defined for injection and standard bolts. And in this case, the scenario of scatter reduction using preloaded injection bolts is also present. Characteristic Hessian curves show that the use of injection bolts contributes to increase the fatigue strength or fatigue life of bolted joints in all fatigue regimes. The detail category for injection bolts is 16% higher in comparison with standard bolts. Okay? The comparison with detail 112 proposed by Eurocode is done, and only one data point is unsafe. Since failure was obtained in S355 steel plates, the Eurocode detail category is not far from the results. However, the slope proposed is not adequate. In this case, the proposal by Tars and Greiner is a very conservative approach, and therefore it is not adequate at all. It's very far from the results. Comparing Weibull distribution and normal distributions for injection bolts, in this case for double shear specimens, for injection bolts, Weibull distribution leads to unconservative approach, while for standard bolts, the result is nearly the same as with normal distribution. So in conclusion, in this study, we observed that the beneficial effects of using injection bolts are mainly in the reduction of scatter and the increase of 16% in the fatigue strength for double shear specimens. It was also found that injection bolts are more suitable for high cycle fatigue regimes, and Eurocode recommendations are not suitable for details in which the fatigue strength is dependent on old metallic materials such as paddle iron. Okay, so these are my references. Thank you very much for your attention.